So last time we saw how to use substitution to help solve a system of equations. Remember that so far we've learned that there's two ways to solve a system of equations. There's by graphing, and there's this way we learned last time called substitution. And so the essential question we're looking at is how can you use substitution to solve a system of linear equations? And we're talking about these steps. One is that you solve for one variable. In other words, you get a letter by itself, like a y equals or an x equals. And once you do that, you substitute that into the other equation. So let's look at what we did last time. Now, last time we did a problem like this, y equals a negative 2x minus 9. So now I want to look at a different type of problem and see if you notice anything different. This was the problem we did last time. Y equals a negative 2x minus 9. Then the second one was 6x minus 5y equals negative 19. Look at this one and look at this one. What's the difference you notice? This one has a letter by itself. This one does not. In order to substitute, you have to get a variable by itself. So looking at these two equations, equation number 1 and equation number 2, which one looks like it'd be the quickest and easiest way to get a variable by itself? Well, equation number 1 to me looks a little easier. Less steps. I'm just going to rewrite them both right here. We're not using this anymore. And this would be really easy to get y by itself and keep everything positive if I just did a plus x to both sides. These would cancel out. I'd have y equals x plus 3. I'll bring this one down. Once you do that, it's the same thing we've been doing last time. It's the same thing as this problem we did up here. So we have a letter by itself here, y. We solve for the variable, substitute it in for the y here. So this y is going to come out, and in its place, we're going to put in what this y equals, x plus 3. So we'll rewrite this equation as 3x plus, but instead of a y, I'm taking it out and putting in the x plus 3. And I'm just writing the rest of this equals negative 1. And it's a simple matter of collecting like terms. 3x plus 1x is 4x plus 3 equals negative 1. Take away 3 from both sides. Scoot down a little bit. 4x equals negative 4. Divide both sides by 4. X equals negative 1. Let's go back up a little bit. So we know that x is a negative 1. We need to substitute and find out what the y is. I'll take that negative 1 and substitute it back into this original equation for the x's. So y equals negative 1. Remember, we found out that x is a negative 1. That's why we put it here for x, the first one. If it's x, then instead of x, we can write a negative 1. Bring down the plus 3. Y equals a negative 1 plus 3 is 2, so y would be a 2. And then we just need to check it by substituting it back into the original equation, or any equation. I'll do that into this equation quickly. So in place of the y, I'll put a 2 equals, in place of the x, I'll put a negative 1 plus 3, and 2 does equal 2. We know 100% that we did it correctly. Yay! All right, here's an extra example not in the book. So again, we want to get a letter by itself. To me, it looks like it's easy to get this x by itself by getting rid of a negative y to both sides. I'll do that by the inverse operation of a positive y. Now that I have a letter by itself, I substitute that into the other equation. Let me just write it first. So instead of a x, since I have x by itself, x equals a y minus 4, I'll put that in place of the x. So it would be 2, instead of an x, it'll be a y minus 4. And then just bring the rest of this down. Plus y equals 4. Distribute. 2y minus 8 plus y equals 4. Collect like terms. 3y minus 8 equals 4. Do the inverse operation of a negative 8 so you can solve for y. 3y equals 12. Divide. Y equals 4. Once you find out what that the y equals 4, I'll put that up here as an ordered pair. We still need to find out what the x is. So how do we do that? Well, if we know the y is a 4, instead of a y, what can we write? Right, write a 4. Bring everything else down. X equals 4, take away 4, which is 0. X equals 0. Okay, and you can substitute both of those in, and you would get the right answer. Yay! Okay. I want you to go ahead and try one on your own. This problem here already has the letters by themselves, so it should be an easier one to try, but go ahead and give it a shot. And write it in your notes. And then I want to also go over this last one here, which is a word problem. These are kind of fun for me. It says a drama club earns $1,040 from a production, so we know the total amount of money they earn. A total of 64 adult tickets and 132 student tickets are sold. Adult ticket costs twice as much as a student ticket. Write a system of linear equations that represents the solution. What is the price for each type of ticket? So we know the amount of tickets sold, and we know the total amount of money that was gained. So we just need to make an equation that would represent that. Okay, so we have adult tickets, which I'm going to summarize as X. Some people like to use an A for an adult. And we have children tickets, which are student tickets, which I'll summarize as a Y. Okay, and we know the adult tickets cost. We know there were 64 adult tickets sold. So the adult times 64 plus the children, and we know there's 132, and that would equal the total amount sold. We also know this, that an adult ticket costs twice as much as a child or a student ticket. So how we abbreviate that as adult equals twice the student ticket. Well, now we have a system of equations. We have an equation at top, and we have an equation below. So we just have to substitute it in. So 64, and instead of an x, we can put in what the x represents, substitute. So the x is actually 2y. Oops, there should be a plus sign, sorry. See, 64 times 2 is 128. We add those together, we get 260y equals 40. Divide both sides by 260. You get 4. Once you found your y, you just substitute it back into the original equation. If you look up here, I'll just do it real quick. X equals 2 times, instead of a y, I'll put in what the y equals, which is 4. So x equals 8. So the answer would be 8, 4. And we can always go back in and check it and see that's right. So an adult ticket costs $8 and the student's ticket costs $4.